All right, today we are doing perpendicularity of a line and a plane. So exciting. All right, so your learning goals for this lesson, you will be able to recognize lines parallel to planes, to a plane or two planes, parallel lines and skew lines. You'll also be able to use properties relating to parallel lines and planes. So let's get right to it. A line perpendicular to a plane. So the definition is a line and a plane are parallel if they do not intersect. Okay, so here's an example of that. Line BA does not intersect with plane M, so they are parallel. Two planes are parallel if they do not intersect. Such as here, these two planes are parallel, will never intersect, don't intersect. Pretty basic stuff. Makes a lot of sense, not hard. It's once we start moving a little bit further along into skew lines. So now the diagram below shows two lines that are in parallel planes. So we would be, for example, given that plane M is parallel to plane N. And even though the planes are parallel, the lines are not parallel because A, B, C, and D do not determine a plane. So they're called skew lines. So even though plane M and N are parallel, and they'll never touch, so meaning the lines on their planes will never touch, even though that's the case, in 3D space, if they're not following the exact same path, then they're not parallel. They're called skew lines. And we'll get into a little bit more with it here shortly and see like kind of what parallel lines are when we're talking about planes in 3D space. So parallelism in space is similar to parallelism in a plane, which is what you're normally working in 2 dimensions. There are a few minor differences, such as the fact that there are no skew planes. Okay, lines can be skew, planes cannot be skew. Planes are either parallel or they intersect, which makes sense because they go on in a couple directions forever, right? So, for example, Theorem 49 states that if a plane intersects two parallel planes, the lines of intersection are parallel. So we're talking about the lines created by their intersection, such as these right here. So that line and that line. These lines would be parallel, the lines of intersection created by that. So that's important. Also important are the following properties relating to parallel lines and planes. First, two planes are perpendicular to the same line. They are parallel to each other, and you can use all of these in proofs. If a line is perpendicular to one of two parallel planes, it is perpendicular to the other plane as well. If two planes are parallel to the same plane, they are parallel to each other. Makes sense, right? If two lines are perpendicular to the same plane, they are parallel to each other. So basically, let's go through a couple of these before I move on. So if two planes are perpendicular to the same line, so meaning, let's say we had a line here and two planes, and this line went through both of them and created a right angle with both of them. That would mean that these two planes would be parallel. That's the symbol for parallel right there. Okay? So there's an example of that one. The line is perpendicular to one of two parallel planes. It is perpendicular to the other plane. So that would be, we're given that this plane and this plane are parallel, and that this line is perpendicular to one of them. It would also have to be perpendicular to the other. Alright, if two planes are parallel to the same plane, they're parallel. So just imagine 3 stacked planes there. So 1, 2, makes sense. All 3 would be parallel. If two lines are perpendicular to the same plane, then they're parallel to each other. So imagine I had a plane here. 1 line, 2 lines, that's perpendicular, that's perpendicular. Okay, they're parallel to each other then because they're perpendicular to the same plane. And it's important that it's got to be the same plane. If a plane is perpendicular to one of two parallel planes, it is parallel lines. It is perpendicular to the other line as well. Okay, so, and that's just a different example. You're given that you've got two lines that you're given are parallel. And you're saying, okay, it's perpendicular to this. Well, then it's also got to be perpendicular to that because the lines are parallel. Alright, so let's do a proof and then we'll be done with the video. So we're given that plane M, which does not seem to be marked, so let's fix that. Plane M is parallel to plane N. Line AB lies in M. Line CD lies in N. And line AC, so this line right here basically, is parallel to line BD. We need to prove that AD bisects BC. How do we do that? Good question. Glad you asked. Number one, we give all our givens. Second, we say that line AC and line BD determine a plane. ACDB. Make sure you name that in order. So we start here and go around. And that's because two parallel lines determine a plane. Remember that from the other day. We're also given that line AB is parallel to line CD. We weren't given that, but if a plane intersects two parallel planes, then the lines of intersection are parallel, so we'll go ahead and mark that on there. So that means that these lines here, let me choose a different color. That's awful. How about red? So this line is parallel to this line, and we were already given that these lines were parallel to each other. So that tells us that ACDB is a parallelogram, because if both pairs of opposite sides of a quadrilateral are parallel, it is a parallelogram. And then finally, we can say, whoa, what is that? We can say that AD, segment AD bisects segment BC, because the diagonals of a parallelogram bisect each other. So it doesn't look too hard on the surface, but it's a little bit harder than it initially seems using all the different properties. So that's it. Hope you took good notes, and have a good one, guys.